The problem I'm showing you tonight is very similar to an SMO Senior Section prep exam, I think, or prep whatever material, but SMO Senior, okay, 2024. Okay, now the question is, what is the smallest positive integer n such that this nested logarithm is defined? Now let's just go back to basics. Any logarithm function, we can say log base b if you want. Okay, and this is a function. This is not b to the x. We must have x positive, strictly positive, because the logarithm function is just the inverse of an exponential function which has a positive range. That means the logarithm has to have a positive domain. So in other words, x has to be greater than 0. Okay? So really we have to just successively force that condition to hold. Now, so log base 3 is the outer logarithm, so it must have a positive domain. That means this circle, I'll go ahead and just this part right here is our new input, right? This entire object, which is a nested logarithm itself, okay? This circled object has to be positive because it's the input to the log base 3 logarithm, okay? So it must have a positive domain, so we're forcing that to happen, okay? Notice it's log base 5 now, okay? Now another thing that's super useful right here is that if you have b raised to the log base b of any expression, and the expression of course has to be positive, but that's kind of transparent here. I'm just gonna, for the sake of generality, question mark, okay? And this is a function. I'll put the parens there just to connote it is a function. We must have, I'll tell you what, let me erase that. All I'm trying to get across right here is that this must equal to question mark, okay? And question mark can be a number, a positive valued expression, whatever, okay? But b and log base b are inverse functions. And so that's all we do all the way through here, okay? Notice that I tried to color code this for your viewing pleasure. Notice how we have a red 5 here and a red 5 right down here. So what happens is this b log base b inverse relationship strips away the log 5, but we have to raise 0. We have to exponentiate 0, which is 1. 5 to the 0 is 1, okay? Now in a similar fashion, this green 7 you see right here, we get it stripped away by raising 1, or 7 to the first power gives us 7, right? And all the way down, okay? This whatever color this is, okay? But notice how we have 2 to the 7th here, which is equal to what, 128? So we see that, and let's not forget what we're doing. We're trying to find the smallest positive integer such that this expression is defined. Not real number, but it's a real number, but it's just a positive integer, okay? So what we would get here is a quadratic that you could solve, but it would be a real number with an irrational solutions. We're looking for the first integer that satisfies this condition. Okay, so what you would have right here is you would have to have n squared plus 3n is strictly greater than 2 to the 7th plus 4, but that's 132, right? 128 plus 4 is 132. Now notice that n equals 10. N can't be equal to 10 here, right? N is not equal to 10. That's fairly close, but you would have 130 is not greater than 132, right? So n equals 11. The next one is going to get the job done. You don't even have to calculate it. You can just tell, right? N equals 11 will be the next integer. You could do, if you want to, this is 121. 3 times 11 is 33. 121 and 33 is what, 154. So that's strictly greater than 132. But the calculations is not even hardly necessary because, you know what I mean? This is 130 and it's just barely less than 132. So the next integer is going to get the job done. So n equals 11 is the answer to the question. Okay, and a guy named Wei Tan, who works for this company in Singapore is the one that presented a problem that was very similar to this. Okay, but the answer here is n equals 11. All right, thanks for viewing.